Hello, this is 2015 TYS Combined Chemistry, Paper 3, Section B. Okay, the periodic table printed on page 20 lists the elements in order of atomic number. Use this periodic table to help you answer these questions. Okay, name any element from period 2 and explain how the electronic structure of this element can be used to determine which group the element is in. Now, period 2, so very important reminder, period 1, there are only two elements, hydrogen and helium. Okay, so before I go any further, go and get a copy of the periodic table and refer to it. Okay, hurry up. Go and get a copy of the periodic table. Okay, so you have it ready. So period 1 consists of two elements, which is hydrogen and helium, and now is period 2. So period 2, the first element would be lithium. You can actually use lithium, beryllium, boron, any element in period 2. So just to make it simple, name any element from period 2. So I choose lithium. Okay, you have to name it, not writing down the chemical symbol, but naming it, which is lithium. Explain how the electronic structure of this element. So you have to write down the electronic structure. So what is the electronic structure for lithium? I use short form. Don't use EC, don't use short form during O level. So the electronic structure for lithium, if you look at the proton number, it is 3. So electronic structure or electronic configuration, there will be 2, 1. Okay, how the electronic structure of this element can be used to determine which group the element is in. Lithium obviously is in group 1. And how is it related to the electronic structure? Because the electronic structure shows 1 valence electron. So you can actually say that lithium has 1 valence electron. Okay, so therefore it is in group 1. Yeah, so you must be very, very explicit in your answer. You have to mention 1 and you have to mention group 1. Cannot just write the electronic structure and then straight away say, oh, because of that, because the electronic structure is 2, 1, therefore lithium is in group 1. Cannot. You have to say 1 valence electron. Okay, so that would give you 3 marks. Very easy. Now for part 2, on moving across period 2 from group 1 to group 7, the character of the elements changes. Describe and explain the change. Now if you look at the period 2, group 1, okay, just a bit of working on the side just to show you. Lithium, it is electronic structure or electronic configuration is 2, 1. And then beryllium, that would be 2, 2. Alright, boron 2, 3. Then you have carbon 2, 4. Nitrogen 2, 5. Oxygen 2, 6. And fluorine 2, 7. Okay, so this is moving across from group 1 to group 7. The character of the elements changes. So what kind of character changes? Okay, so the character in this case refers to the metallic and non-metallic. You can see that these two are metal. Boron is in group 3. It's actually a non-metal. Okay, because it is on the right hand side of the staircase. Carbon non-metal, 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 non-metal. So it's from metal to non-metal. So the changes would be from metal to non-metal. So you can say the elements change from metals to non-metals. Now how do you explain the changes? So this one will be 1 mark. The element changes from metals to non-metal will be 1 mark. But how do you explain? So the explanation will be 2 marks. So moving across from left to right, what happened? What changes that you can see? So if you move across, okay? So you can just move across from group 1 to 7. What happened? The number of valence electrons actually changes, right? The number of valence electron, so I'm going to write it in point form. The number of valence electron increases. When the number of valence electron increases, what happened to the attraction forces? So the attraction forces between the nucleus and the valence electron will be stronger because you have more valence electron for the nucleus to attract to. Okay, so this one is stronger attraction forces between nucleus and valence electron. Okay, so the nucleus or the protons in the nucleus get to attract more valence electron. Okay, so the attraction is stronger. When the attraction is stronger, is it easier or harder to lose the electron to become positive ion? Okay, is it easier to lose one compared to lose two? So it's actually easier to lose one compared to losing two valence electron. Okay, so as you go from left to right, it becomes harder. Okay, this one is easy, this one harder. Alright, so harder to lose electron to become positive ion. Now, when it is harder to become to lose electron to become positive ion, that means that the metallic property actually decreases, because the metallic property or the metallic character of the element depends on how easy it is to lose the valence electron to become positive ion. So if it is very easy to lose electron to become positive ion, that means it's very metallic. But now it's becoming harder and harder to lose electron to become positive ion. That's why the metallic character actually decreases. Okay, metallic character decreases. Okay, harder to lose electron. Harder to lose electron, meaning that when you go to like 5 and 6, okay, 2, 5 would tend to gain 3 electrons, right, to become negative ion. This one would tend to gain 2 electrons. So which one is easier to gain electrons to become negative ion? So obviously it's this one. And then this one is even easier, because it's always easier to gain 1 electron compared to 2 electron compared to 3 electron. So that means easier to gain electron to become negative ion, and that would means that the metallic property, metallic character, non-metallic character increases. See, metallic character depends on how easy it is to lose valence electron to become positive ion. When it is very easy to lose, very metallic. Non-metallic character depends on how easy it is to gain electron to become negative ion. If it is very easy to gain, non-metallic character increases very high. So this would be your explanation. So all you need to do is just to join all these sentences together. Alright? So from here you can better see from left to right. So in this case, it would be from top to bottom, moving across the period. Okay, moving across the period from left to right. The only changes is the number of valence electrons. So the number of valence electron increases, stronger attraction. Stronger attraction means harder to lose the electron, the valence electron, to become a positive ion, which means that it is easier to gain the electron to become negative ion. So both of these, easier to lose electron, easier to gain electron, it has an impact on the metallic as well as non-metallic character. Okay, so that would be 3 marks for part A 2. Now let's look at the next question. Now the next question is the element with atomic number of 85. Atomic number 85, or the proton number 85. We can look it up in the periodic table. It should be astatine. Okay, it is so unstable that it has never been seen by the naked human eye. Very, very unstable. So consider the properties of other elements in the same group. So same group, what group is it? This is group 7, halogen. Predict one physical property and one chemical property of the element with atomic number of 85. This is very easy because chemical and physical and chemical property of acetylene. So all you need to do is to look it up in your textbook or in your mind map. Acetylene, what are the physical property? There are many. Okay, it is black color. Or if you don't want black color, you can say it is solid at room temperature and pressure. Or you can write it is diatomic. Okay, many possible answers for this physical property. How about chemical property? So you know that group 7, they are actually very reactive non-metal. They are very reactive non-metal. Okay, that would be the chemical properties. It's about reaction, reactivity. Write a balanced chemical equation to represent the chemical property that you have described. So how do you write an equation to show that it is a very reactive non-metal? It is a very reactive non-metal. You can actually refer to your periodic table. Here you go. This one, very reactive non-metal. And the reaction is, it will react with any metal to form halide. So an example, chlorine and sodium to form sodium chloride. So you can actually write down the chemical equation. Okay, AT plus Na, right? Then NaAT. Is it correct? Of course it is wrong, because halogen is diatomic, meaning that if you want to write halogen as itself, not as part of a compound, by itself, it must be diatomic. 2 atoms combine to form a molecule. So it's acetylene molecule plus NaAT, and then put a 2 here, put a 2 here to balance the chemical equation. No need to write down the state symbol because you are not asked to do so. That will give you the 4 marks. So simple. So this one will be physical property 1 mark, chemical property 1 mark, equation, as well as balancing the chemical equation, there will be 2 marks. So generous. Okay, number 9. The speed of a chemical reaction can be changed by increasing the pressure of reacting gases, decreasing the concentrations of reacting solutions. State the effect that each of these has on the speed of reaction. So which means that you have to tell me, increasing the pressure of reacting gases, would it increase or decrease the speed of a chemical reaction? So simple, increasing the pressure definitely increases. So if you, okay, I'm just going to write down in short form, and again don't write like this in O level. If I increase the pressure, then of course the speed of reaction will increase as well. Alright? And then decreasing the concentration. If I decrease the concentration, of course the speed of reaction will decrease as well. So if you get this question wrong, I'm not sure what happened to you. Now for part 2. Okay, a bit of saliva here. Okay, for part 2, use your knowledge of reacting particles to explain your answer to A1. That means why increasing the pressure, the speed of reaction will increase. Now, this part again, it's straight out from the textbook or the mind map. This is about pressure, right? So, it means when I increase the pressure, what happened? When I increase the pressure, what happened? The reacting particle, or in this case, the particles of the gas, will be closer. So there will be more collisions and more effective collisions per unit time. Actually, there should be a per unit time here. So faster speed of reaction. So all you need to do is, again, I write down in short form, increase the pressure, the reacting gaseous particle. Okay, use back the word. The question say reacting gases. So you must answer according to the context of the question. Reacting gases particles would be closer. Okay, remember when you answer the question, must answer according to the context of the question. Reacting gases particles closer, so that means more effective collisions per unit time, and then speed of reaction will be faster. That's it. How about decreasing the concentration? Decreasing the concentration. If I decrease the concentration, what happened? If I increase the concentration, there will be more reacting particles per unit volume. See, this keyword is very important. Per unit volume. Okay, and then the rest will be the same. So all you need to do is, when I decrease the concentration, there will be lesser or fewer reacting particles per unit volume. Okay, and then the rest would be pretty much the same, which is lesser effective collisions per unit time, and then slower speed of reaction. Okay, so these two so when you try to explain all those factors affecting speed of reaction, actually the only difference is this part, this and this. Yeah. So if it's talking about temperature, then there will be reacting particles have more kinetic energy. Yeah. And then if we are talking about particle size, or small particle size, larger surface area for the reacting particles to collide on. Yeah, the only difference is this. The rest they are all the same. Okay, after this, the next one will be your number of more or less effective collisions per unit time. Yeah. Alright. Number 9, very simple. 5 marks. My God, it's so simple. But you got to think, got to answer according to the context of the question. Okay, for part B, an experiment is to be carried out in the laboratory to measure the average speed of a chemical reaction. Okay, average speed. So average speed means, for example, the total volume released divided by the total time. That would be the average speed. Choose and briefly describe a suitable reaction. Describe a suitable reaction. Describe the measurements you will take. Now, so this one is similar to a design and describe an experiment. So for this kind of question, it is really strongly advisable for you to draw the diagram. So basically, in order to answer this kind of design and describe an experiment, it's better to follow this step, which is DSOC. D stands for diagram. This is the acronym to guide you. I mean something to guide you lah. S stands for steps. O, observation, and the C would be the conclusion. That means how do you achieve the aim of your reaction, which is to find out the average speed. So DSOC, DSOC, diagram, steps, observation, and conclusion. So first thing, draw the diagram. Okay, any reaction, but try to recall speed of reaction. Speed of reaction chapter. Speed of reaction chapter. What kind of method do we use to measure the speed of reaction? So if you look at your speed of reaction textbook, or the mind map, you can see that either this or this. Yeah, So this one I would be collecting the gases. I think that's a more common one, but either way would be okay. So you can draw the diagram. Now again, I'm just going to anyhow draw the diagram. You can draw better than me. Okay, remember when you draw diagram, what must you bear in mind? You must always bear in mind that you have to always use pencil, not use pen. Remember, must use pencil to draw diagram. And also, like drawing dot and cross diagram, always use pencil. Okay, so over here, it's just HCl. When you draw diagram, you must label. Okay, and this one would be the magnesium ribbon. Remember magnesium ribbon? In your practical, you always use a magnesium ribbon. And then this is the gas syringe. Yeah. So that's all. That's your diagram. And then write down the steps. What is the first step? So you have to put what? Put how much of a magnesium ribbon? Maybe 2 strips. 2 strip Mg ribbon into conical flask filled with okay, I'm just going to write a lot of short form. Filled with maybe 20 cm cube, 1 mole per dm cube HCl. 1 mole per dm cube is the concentration. So when you want a solution, it is good to give the concentration as well as the volume. Then after that, okay, put it inside. Then straight away you have to start the stopwatch because you want to measure the time. Okay, this is the stopwatch. Stopwatch must draw stopwatch. Then start the stopwatch. Start stopwatch. Then what happened? When you put the magnesium ribbon into the HCl diagram steps, observation, what do you see? Okay, gas bubbles. Gas, yeah. How come double S? Gas bubbles. Observe. Then you must explain what is this gas bubble. Okay, explain your observation. Due to release of H2, which is collected in gas syringe, something like that. Okay, then after that you should wait for the experiment to stop, right? Then how do you know the experiment has already stopped? That means when there is no more gas bubble, when no more gas bubble is observed. Okay, I'm not going to write the full sentence. No more gas bubbles. Stop the stopwatch. Stop the stopwatch. And record volume of H2. Okay, in gas syringe. So that would actually take care of the first part. Anything else I'm missing? I don't think so. Okay, this is observation. I mean the diagram steps observation. Conclusion would be for step 2. For part 2, describe how you will determine the average speed of your reaction. So this is part 1, and then for part 2 is how do you get how do you determine the average speed of reaction? So for part 2, that's average speed would be the total volume collected, volume of H2 collected that you recorded in step 4 divided by the time taken. Yeah, you can just write it like this, and then state the units in which the speed of the reaction can be measured. What will be the unit? Volume of H2 must be cm cube. And then time taken, well, it can be in minute, can be in second. Yeah, so that would take care of this question, 5 marks. Okay, so remember, whenever you say describe or design an experiment, okay, try to make use of this DSOC diagram, the steps, observation, what you see when you mix the two chemicals together, as well as the conclusion, which is how are you going to achieve the aim of your reaction, which is to measure the average speed of your reaction. Okay, for number 10, metals can be placed in a reactivity series. Although carbon is a non-metal, it can also be placed in this reactivity series. Okay, I shift my fan a bit. It's a bit warm here. Okay, it is placed between magnesium and lead, okay, carbon. So metals are extracted in many different ways. Use the reactivity series with examples to explain the following. So you have to use the reactivity series. So it's actually better to just write out the reactivity series. Okay, so remember, you got to memorize this. Okay, the reactivity series, your carbon is here. Some metals can occur in the ground as a uncombined metal. You have to give examples. So, which one can be occur in the ground as an uncombined metal? That means it doesn't form compound. That means it is super duper unreactive, which is Ag. So Ag here is unreactive. Is unreactive. Unreactive means it will not combine with other elements to form a compound. With other elements to form compound. Okay, that would be identify the metal, give examples. Okay, then for part 2, several metals occur as oxides. The metal can be extracted from some of these oxides by heating with carbon. For other oxides, so some they are oxides and you can extract the metal by heating it with carbon. Then of course these are the ones which can be extracted by heating with carbon. So which are the oxides? So you can just say metals below carbon is less reactive than carbon. So you have to explain, it's less reactive than carbon. So which means that they can be extracted from their oxides by heating with carbon. So you have to give examples, right? Give examples. So for example, there are so many examples. Zinc, iron. So an example is zinc can be extracted from zinc oxide by heating with carbon. Then you do the same for other oxides. This method cannot be used. So you can say metals above carbon is more reactive than carbon. So which means that they can't be extracted from their oxides with carbon, which means that they can only be extracted using what method? So all these are, how do I extract, let's say magnesium from magnesium oxide? By electrolysis. Okay, so you need electricity, you need to pass electricity through it, then only the metal can be extracted. Okay, so that would take care of this 5 marks. So this one quite a lot of writing, but then they are all quite straightforward. The most important thing is to give examples. Again, talking about example, you can give example. Magnesium can only be extracted from magnesium oxide using electrolysis. Okay, you can continue from here. Alright, for part B, iron and calcium require different conditions to react with water. By referring to this reaction condition, justify the relative positions of iron and calcium in the reactivity series. So, iron can react with water, but under what condition? Is it cold water, hot water, or what? Yeah. So again, iron, refer to your metals, the first page of the mind map. Iron can only react with steam. Okay, to form what? Okay, actually no need to say to form what. How about calcium? Calcium can react with cold water. Yeah, so from here we can actually conclude that calcium is more reactive. Hence calcium is above. Justify the relative positions of iron and calcium. Relative position in the reactivity series. So which means that you have to say above or below. So calcium is above iron in the reactivity series. Okay? You should not say calcium is more reactive than iron, because relative position, where are they in the reactivity series? So should be calcium is above iron in the reactivity series. And then for part 2, write a balanced chemical equation for one of the reaction. So the simplest one is calcium plus water. You get calcium hydroxide and hydrogen. Okay, so 5 marks. 1, 2, 3, 4, 5. So 2015 section B, it's a bit more challenging, but again, try to strategize it. Reserve at least 25 minutes for this question, for the section B. And try to always look at the marks allocated in order to determine how much you can write. And most importantly, read the question very